All right, this is Mr. Werik. I'm going to be talking to you today about these notes, just so you can still hear me say it, even if I'm not in the class. So let me get my mouse over here in the appropriate spot. We're here on 214, that's conditional statements, okay? So on this first slide, what are conditional statements? We call them if-then statements. We have a hypothesis, we have a conclusion. If it is raining, then my roof will get wet. So after the if, it is raining, that's my hypothesis, and then my roof will get wet, that's my conclusion. If it is Tuesday, then tacos are on sale. So this is my hypothesis, this is my conclusion. A number is divisible by 10 if its last digit is 0. So this one, you're still following the if its last digit is 0. So its last digit is 0 is my hypothesis. Then it is divisible by 10. That would be my conclusion. The hypothesis you usually label with a P. The conclusion is labeled with a Q. So if you write this in the notation for these, you say if P, then Q. Okay, P is my hypothesis. Q is my conclusion. And the if and then are not part of the hypothesis or conclusion. They just kind of indicate where those are going to go. The last thing that's on the notes for this section is the counter example. If you have a counter example, that's the example that shows that a conjecture is false, okay? It gives an example by saying this is where it's not true, all right? So our example, the sum of two integers is always even. So if it is the sum of two integers, that's whole numbers, then it's always even. That's our if-then statement. So our hypothesis is we're going to add two whole numbers together, basically, and then our conclusion is it's going to come out even. So we look right here, 1 plus 1 equals 2. That seems to be proving it correct, but look right here. 1 plus 2 is equal to 3. 3 is not an even number. Even numbers are divisible by 2. So 1 plus 2 equals 3 is a counter example. It shows that conjecture is not true. Then we look at the section of the notes for 215, which is the converse, inverse, and contrapositive statements. Make sure to just go through on these notes, write stuff down in your notebook, paraphrase, make it work for you. And again, this is a YouTube video. You can pause it while you write the stuff down and then start me back up when you're ready to move on. So the related conditionals, every single conditional statement, every if-then statement is going to have three related statements. They're going to be the converse, inverse, and contrapositive. So when we put these together, we have our statement here. If two angles have the same measure, then they are congruent. So when we have the converse of this, we switch the hypothesis and conclusion. So if two angles are congruent, then they have the same measure. We switch the order of these, that's converse. I usually draw like a shoe next to this one. Converse is a brand of shoes. Shoes help you move. We are going to move these around. We're going to switch them where they are. The next one that we have is the inverse. So we have our same statement. If two angles have the same measure, then they are congruent. When we have the inverse, we're going to add the word not. We are going to negate both the hypothesis and the conclusion. Don't just pick one. So if two angles do not have the same measure, then they are not congruent. All we have to do is add the knots. We don't have to worry about whether it's going to be correct or not. We're just going to add those knots and then move from there. The last one that we have is going to be the contrapositive. The contrapositive is where we're going to do both things. So contrapositive has two parts. We need to do two things. Okay, so we switch the hypothesis and the conclusion, and we're going to negate both of them. So look at my original statement. If two angles have the same measure, then they are congruent. Here's my contrapositive. If two angles are not congruent, I took was at the end, I moved it to the front, I added not. Then they do not have the same measure. I took what was at the front, I moved it to the end, I added the word not. Now, the last thing that we're adding on here is the set of truth values. Conditional statements can be true, they can be false. And when you do your assignment, you're going to need to write both kinds. Okay, so if we go back in the notes to where we had the example, that counter example, we have a statement here that is false because it's not always true. Okay? It has to always be true for us to say that that statement is true, not just sometimes. The truth values of all these statements work in pairs. If the original statement is true, the contrapositive is true. If the inverse is true, the converse is true. If one of them is false, the paired one is going to be false. So if my original statement is a false statement, the contrapositive is also going to be false. If the inverse is, because we added the nots, it makes that original statement false, the converse is also going to be false. These work in pairs. Okay? Your assignment is going to be in Schoology, and it will require me to finish writing the instructions on this set of notes. But you're going to need to write your own statements for one of them, and you're going to need to write two of them that will be false. So think about some if-then statements. Think about ones that would be false. If today is Wednesday, then the sky is going to be green. That doesn't usually happen, so that could be a false statement. Don't use that one on your paper. And then the next page is going to require you to take them and write the converse, inverse, and contrapositive, so make sure you know what those mean. We'll go over this assignment a little bit, at least at the start of the day on Friday. Remember, when I come back Friday, we will work on the review, and then next week, Monday, we'll have a test.